Hello YouTube viewers, welcome to my show Computer Viewers Display. In today's episode, we're going to talk about micro LEDs display technology. So let's dive right into it. Well, first we have to understand what the heck it is. In simplest term, it is a backlit free display technology. Basically, each sub-pixel, basically a pixel is divided into three core categories, R, G, B. Each of them is called a subpixel. In this scenario, subpixel itself will illuminate the light. That is the core difference between LCD and basically micro LED. Now subpixel, now we have this kind of technology. If you have seen any event display which are like stadium side or a concert and all that, those are using these itself. Now again, it's not necessary they are using exact same these three LED. Sometimes they have RGB LED itself, like all these three diode would be in one LED. They use that. Now again, it does work, it's awesome, and you can find them in like 200 inches to 500 inches display size, or sometimes even larger than that, and it's quite successful, popular. However, their inherent limitation is that you cannot get close to them. Like, not only it will roast your eyeballs, it's if you get close enough you can easily see individual pixels. So PPI, basically pixel per inch, is not that good. So somebody came up with the idea, hey, why not we make this as small as basically pixels on your sensor. If you've seen your camera sensors, those have something that is small enough to compare against this. Basically pixels in your smartphone and or DSLRs are generally measured in micrometers. That's why the micro LEDs are here. This is also in micro scale, so it's quite amazing to get it down to that small scale. It makes it unperceivable to anything. Like, even you need a good microscope to see it, and you need an electron microscope to actually make out what the hell is happening. So you can understand, like, somebody took this, made it as small as that. On top of that, you might wonder how the heck it's possible. Like, these puppies are big, hot, and complicated structure. How the heck somebody shrunk it down to this much? The foundational reason why this is possible now, not like 50 years ago, is simply because we are moving away from silicon and we are moving into gallium. Now, if you're familiar with technologies, R&D, behind the scene kind of technology, you must be hearing the fact that we have reached a maximum potential of silicon. Like, if silicon had, let's say, 100 capabilities, we have reached a point where we are extracting 99 out of it. It's like we cannot push it any further. Like, we can refine the design, but we cannot get more out of it. It's like, yeah, this is efficient in this design, it's a bit more, but you get the point. Like, we maxed it out. However, there is another semiconductor. There are a lot of semiconductors in basically periodic table. Gallium is one of them. However, gallium is not that textile, basically it's not as awesome as silicon. However, it is awesome at power handling. That is why gallium, like you can right now buy gallium based basically chargers, turbochargers and superchargers, which are like 20% smaller than silicon counterpart. Again, that's how it starts. Over time, gallium will take over almost all power adapters and things of that nature, simply because it's much more efficient. And I can easily see electric cars are also investing into this, simply because it's much more efficient and much more power handling capacity. Not only it will make you smaller, lighter, it will also make you more efficient. So that is the trend that is happening, and on this trend somebody made this using gallium as a backbone. So first thing you will think about, don't we have this kind of technology in terms of OLED? Short answer would be absolutely yes. However, you have to understand the O part, basically organic compound, aka carbon polymers that we have, it degrades inherently by use. It's not independent of the use cycle. Basically, it's not something, it does not care. Basically, like, if you take LEDs, normal good quality LEDs, it can last for 20,000 hours without even giving it up, unless you roast it. So when you are comparing that to OLED is like in 100 hours to 800 hours. If you have continuous use, it will be like, yeah, I can't take this anymore. So it degrades over time. Now, when I say degrades, it does not mean like it becomes 100% useless, but over time you can easily spot it, like, hey, dude, this is no longer working for us. So it's okay for mobile phones, because nobody is expecting their mobile phone to be there for like more than few years. Like, not even few years. People, I'm replacing my phones in around every 2 years, or because I buy mid-range phones. But you get the idea. Like, people are expected to change their mobile phone. However, for TVs, for computer monitors specifically, it's something that you put and forget. OLED is not fitted for that, because it will degrade over time. And in terms of brightness, how bright it can go, it is not that bright, simply because it's something else that is trying to be something else. So it does emit light, a lot of light. 800 nits is no laughing matter, because if you have a cheap monitor, there is a very good chance it's limited to 300 nits. So you can understand 800 nits is no laughing matter. However, it's useless in outdoor. If you go into any cinema production and if you see monitors that are used in broad daylight, those start at 1000 nits and go as high as 5000 nits. So you can understand that it's no laughing matter. Like, like 800 is a serious limitation. It's not a, oh, it would be better to have it, it's no issue if you don't know, it's an issue. On top of that, because of HDR specification, the maximum brightness you need for full HDR specification is 1000 nit. So can AMOLED push that? Yes, they can push it, but they will degrade themselves much faster. So LG would be in a position where like, I can make OLED that is awesome, but it will last only 1 or 2 years. And if you are spending in that kind of money, people are like, dude, I want this thing to last. So you get the idea, like it's not that bright, and not only that, it does not last very long. On top of that, because it's a quote unquote things, trying to do quote unquote things, it's not very efficient. Basically, if you take the electron to photon conversion efficiency, it's not that high. Basically, it's much better than LCD, but it's not as better as it could be. However, it does have one ace up its sleeve. It's flexible. We have been making it for long enough, and we know how it does. Is that we not only can make flexible out of it, we can make stretchable out of it. This is a AMOLED display technology that was demonstrated by Samsung in 2017. Yes, that's a stretchable, like that literally pokes out and it still keeps working, and it also goes down also. So it's not like stretching in one direction, it has dual direction stretchability. So OLED will be there. I can easily see OLED if folding phones take over, flexible smartwatches take over. I can easily see OLED to be there like forever. It's just that for mobile phones, micro LED will replace it. So what are the main benefits? Why we want, like, we just went into OLED. Heck, I got my first OLED device, my first mobile phone with OLED now. So like, why the heck we want to replace it so quickly? Is there any tangible benefit? First benefit is basically it's longer lasting, because again, now you can have a micro LED TV monitor or computer monitors that will last for decades. That's the first advantage. Second, it's more efficient. So basically, in terms of watt to photons conversion, it's much more efficient. So every that also reduces the heat output of your monitor and display, and all that also makes it much more efficient over time. So not only you will get something that has the same contrast as OLED, it will be just much more brighter, and it will also go last longer while consuming less power. So all those is awesome. And in terms of how bright it can be made, here's the interesting part. It can push upwards of 1 million nits. As of now, the only way to achieve that kind of brightness is using laser projector systems. So why is that important? Now you may think, okay, that's something that somebody did in lab to show it or prove it. Well, this allows some very interesting thing. Think of it this way: your smartwatch, while you are indoors and all that, you barely need 500 nits. It's like more than enough. However, you are outdoor, and if sun is like this, coming in this angle, your display has to crank itself to 20,000 nits. Again, if it's made out of micro LED, for that short burst, it can do that, and you will be like, hey, I can easily read whatever the hell is happening on my display. So that allows sun time uses. So you can have outdoor televisions or flatter things with much more dynamic rays. That's why you will no longer need local ray dimming for getting high contrast. So it's quite useful. On top of that, right now, if you want awesome contrast in your projectors, the only option is DLP, simply because it bounces light off in the other direction if the pixel is supposed to be black. So LCD based projector has the same issue. It's just that black does not go to black. DLP does allow black to be black. However, it's just wasting light, simply because that's what these mirrors are doing. Is like, okay, if supposed to be black, okay, point it into black wall. If it's supposed to go out of lens, point it out of lens. If it's supposed to be black, just point it here. So you get the idea. Like, it is inherently wasteful. Now these puppies, I provided a lot of videos down below. I would urge you to see that. They are making something that can directly replace this chip, and not only will it make it smaller, much more efficient in every way, overall it will be much more longer lasting also, and cheaper also. So like, again, once it reaches mass production, not right now, once it reaches mass production, so that is quite amazing. That and in the future you can have a luxurious mobile phone which has just like, hey, put it in this cradle which has lens arrangement and all that, and have the 100-inch output, just connect it through a power, and it cranks the display brightness. You may need some cooling in that point, but you get the idea. You can just have your mobile turn into a very good basically projector. So that million nits is not just a luxury show off, it's a desirable thing. Not to mention, VR will also benefit from that. However, AR headsets, basically AR headsets, needs this, simply because AR right now at night works awesome. The moment you go in broad daylight, it's like useless. So you need, in those sort of scenarios, they are saying they need minimum of 20,000 nits. Otherwise, they have to somehow make sure that light directly gets into your eyes, which is troublesome to do with, even with fancy waveguide technologies and all that. So this kind of brightness is needed. So these are the main benefit. You will have something that can go YOLO bright, not do that much more efficiently, and last longer. So it's basically turbocharged OLED technology. So then the question becomes, when will you see this? As of now, as of me making this video, three major manufacturers that are into it is basically Sony, Samsung, and LG. And Apple has also invested a lot of money into this, and I mean a lot of money poured into this. So every Tom, Dick, and Harry is working on it, and not to mention there are 100 startups that are making specific products for this, specifically that projector side that I specified. So you can easily expect by 2025, high-end equipments will start using that. Same way OLED first started to come in high-end equipments, then it started to come down to us. Same will happen with basically micro LED. You can easily see that. Heck, right now you can buy that, but again, right now the price is like, if you have to ask the price, you can't afford it. So right now you can buy Samsung wall and basically micro LED singles from LG. But again, right now the prices are like, you must have at least one yacht, two, three Ferraris, 1.8 Lamborghinis and all that. So right now they are like, show off kind of piece, but again over time they will become like, okay, high end equipment. Like if you can save up enough money for long enough, you will able to buy that. After that, it will become slowly over time, it will become more adopted. But this technology truly has the advantage of removing OLED from everything and removing LCD from everything, because right now you still see LCD everywhere, because OLED's brightness limitation and short lifespan. This can truly kill off LCD. It's like, yeah, LCD is gone. So, and wherever you need flexible display, you will use OLED. So this can truly kill LCD. So that is a very big thing. And you also have to understand this aspect, that as our technologies are going, the amount of time it takes from concept to actual product, it's shrinking. Like I saw some designs somewhere in like, basically OLED technologies. Like, yeah, in 1990 somebody figured out, hey, we can make OLED. It took many years before somebody made a mobile phone. It took many years before I can afford that. So right now that time is shrinking. So people can easily expect by 2030 this micro LED to be like, yeah, my projector is micro LED, my the smart camera is micro LEDs and all that jazz. I can easily see that. So this was my presentation on micro LEDs. I hope you liked it, learned from it. In that scenario, please click the like button if you liked it. And if you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me your extra disappointment. Please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.